Good morning, everyone. Hope I'm audible and you can see my screen. We will start the lesson. Sometimes today the lesson might be a little bit longer than the usual lecture, but I'll try to minimize. Minimize means try to complete within 2 hours. If not, sometimes it might extend to another 15 to 30 minutes. We'll try. So today discussion will be done in the context of networking. So first of all, what's a computer network? Now, a computer network is a group of computer systems. It's a group of computer systems and other computing hardware devices that are linked together through communication channels to facilitate communication and resource sharing among a wide range of users. So there are few key terms in here. It's a group of computer systems. It's a group of computer systems. So there might be different laptops, different desktops, and other computing hardware devices such as mobile phones. And there might be a printer. It's also a computing device. Other computing hardware devices that are linked together through a communication channel. So it might be a wired communication, it might be wireless communication through communication channels to facilitate communicate. So what they want to communicate with each other. This computer or laptop needs to get a printout. So this client is sending a request to this printer. I want to print this document. So it's a communication. And sometimes it might be intercommunication among two computers. That's a communication. And resource sharing among wide range of users. So what is this resource sharing means? Actually, this is another resource sharing. Printer is shared among these computers. This printer is shared among. Sometimes your mobile phone is shared among the other computers. Or your computer might share among different mobile phones to share some sort of document. Think a PDF, you want to share a PDF. It's shared about resource sharing. That is the resource, your PDF, or it might be a Word file, or it might be some another document, or it might be a music file, whatever. So this is a basic idea of a computer network. Why we want networks? The first and foremost requirement is communication, because we want to have communicate in between different computers or different hardware devices. So you may realize we need to be have a proper communication. It's mandatory to have a proper network. If not, the communication channel would not work properly. The second one is resource sharing, as I previously discussed. The goal is to make all programs, equipments, and especially data available to anyone in the network without regard to the physical location of resource or the user. Now, what is this resource sharing means? Programs or equipments. Equipment means it might be a printer, or it might be a scanner, whatever, a device, and especially data available to anyone. Now, think there's a file is shared in a computer in your network, then without regard to the physical location. Sometimes you might be in a different location, geolocation. You might be in a totally different geographical different location. You might be in India, or you might be in UK, you might be in US or Japan or whatever country. It's okay. But The resource can be shared if you are in the same network of the resources or the user. So we don't think about the user. We don't want to think about the user. We just think about the computer that is connected or device that is connected. So resource sharing means whatever a network, regardless the geographical location and regardless of the person who is using, if the computer has sufficient privileges to use the device, then we can perform as resource sharing. Hardware resources can be shared. As an example is a printer. If you are working in a company, for entire company there might be maximum 3 to 4 printers might be there among 500 people working. So the all 500 your co-workers are using only that 4 printer. So that means you have shared a hardware device. And softwares, there might be desktop sharing. Softwares might be there. And especially currently, if we think about softwares that is more flexible to communicate in between a local area network or a small network, is widely available to perform different tasks inside the company. And information, the sharing the data. We want to share the data always. In majority of the situations, we want to intercommunicate in between different computers. So that is another aspect under the resource sharing. And again, the location independence, users can access their files from anywhere in the network. So if your mobile device is connected to your university network, we'll get an example. If your mobile phone is connected to your university network, regardless of you are in a lecture hall or you are in the library or wherever the person place, you would able to access some sort of resource. It might be not your mobile phone, it might be your laptop even. You can access resources without care about the geolocation, where you are located, where your computer is physically located. This is the location independence. Now, what are the components in a network? First one is the client computer. So the client computer means the computer that connects to the network. The client computer means the computer that connects to the network. So basically, it's your laptop or your desktop that is connected to the network. That is your client computer. So hereinafter, if you see a word like client, that means the computer that is you are using. The second thing is server computer. You have heard this word server. What's the purpose of a server is serve to the clients. Serve to the clients. Now you all are connected to a one server probably sometimes. And you all get the information from that one single server. So that means the server computer serves for you. You are requesting some information from the server and server is granting information to you or data to you or the resource located in the server. If you access to the UGC handbook, that means you all requested the single resource that is resides in a server location. So you all access to that single location. So the server would serves or helps to many number of client computers. That's the purpose of this server computer. network interfaces or network interface cards. So this is one example of this network interface card, usually on board. What's the meaning of this on board? Sometimes you might heard this word on board. On board means it's inbuilt to your motherboard. So you don't want to have a separate. So you don't want to have a separate physical device to connect with the internet if you have on board NIC. So that means your network card is already built in your motherboard. Motherboard is the circuit in your computer, the main circuit in your computer. That's motherboard. So this is inbuilt. That's the meaning of this onboard. Each computer on network contains interface device to link the computer to the network. So what's the meaning of this case is, if you don't have a network card, you would not able to communicate. So that means you should have a proper working network interface. It might be wireless interface, it might be wired interface. Connection medium. This is another important component in the network. Connection medium. The connection medium for linking network components can be a telephone wire. So we want to connect in between. As I previously told, we want to connect in between the hardware devices. At that case, we want a communication channel. It might be a telephone wire or coaxial cable, or it might be a signal. Signals can be having large range, some sort of wireless signal. These are wired communication channels. So you want a cable to connect with the internet, isn't it? You want a cable. If it is a wired network, you want a cable to connect. So that means you are using one of these solutions. Or if you are using Wi-Fi or WiMAX kind of solution, then you might use radio signal, a kind of a radio signal, or it might be a wireless signal. Another component in a network is hub or a switch. Hubs connect network components, sending a packet of data to all other connected devices. So these are the devices that communicate or that helps to communicate in between the hardware devices. So these components now computers are transform data, sending data through a packet. Packet means think something wrapped. You know, it's a packet, milk packet, whatever. It's a packet. In the same way, data is wrapped as a packet. This packet contains lot of data, such as from where it's generated, from where to its route, or from where it moves toward, or what's the end location, what are the information that I'm carrying. That kind of information is stored in this packet. So hubs are connect network components, and these are sending the packets of data to all other connected devices that are, if your hardware device is connected to this network, if your hardware device is connected to a network, now your computer is here and another computer is here, you can't communicate in between. without a proper device. So this is a switch mainly. Now, this is your computer, this is your laptop. There are might be some other laptops. So you need these communication channels. To have these communication channels, you need another hardware component. It might be a hub or a switch. Switches can filter and forward data to specified destinations. So it routes to this laptop. Your computer needs to transfer transfer some sort of information. So it can be transferred via this switch. This switch is supporting to transfer in between. That's the main purpose. Routers. Device used to route packets of data through different networks, ensuring that data sent gets to the correct address. Now you are in a different location, sorry, a different network, and your receiver is in another. Think it's a different network. So you two needs to communicate in between. For that, we need another hardware device known as router. If your sender is sending some sort of information to this receiver, this router is having good understanding what is this sending information and where should it goes to. We will discuss how this communication, how these identifiable things are communicating in between. But for now, what you have to understand is if the computers or the sender and the receiver is in different networks, then the router would perform the required activity to transfer the data to the correct end. Now we'll discuss about switch a little bit more. A switch, a network switch, is a networking hardware that connects devices on a computer network. So the switch is mainly focusing on connecting. Switch is mainly focusing on connecting devices in your network. This is a switch. This is your computer. This is your laptop. This is your computer. So you need to communicate in between. This device is performing packet switching to receive and forward data to the destination device. So what's the purpose is I, I have told you the transfer, the data is transferred through a packet. All the required information is collected and put into a bag, and we tie the bag and transfer it. So that is the packet. This packet contains numerous information, as I previously told, and the switch is performing the required activity. So switch is packet switching to receive and forward. So it receives the data set and it forwards the data to the relevant place. Now there are number of network switches are available based on the ports. These are ports. These are the network ports. You may see these are the network ports. This switch contains 5 ports. This switch contains 48, sorry, 24 ports, and this switch contains 48 ports. So this might be very small network, the devices, very limited devices, but this might be a little bit larger. But for the case we have to get sometimes in many cases rack of switches, lot of switches to have proper communication, to build a proper communication. Now we will get a problem like this. Now we have a printer, and there's a your computer. Now how the Now we think few more computers. It's in a network, a lot of computers are there, and we want to communicate to this printer. We want to send your PDF to print. This is the printing device. There are a lot of computers in this network. How this communication would done? Now you might think I just plug my cable and do the print. If you have a printer in your home, you just plug, right? You just plug and play. You just plug your printer and it installs the required softwares or the drivers. Then it print. But the case is, if you are connected to a large network, the case is if you are connected to a large network, lot of computers are communicate each other. So you want to communicate your document specifically to this printer. In that case, we have to use this switch. Switch is a hardware device, connects connects devices on a computer network. This device performs packet switching. So this laptop transfer information of a packet by sending. This is from laptop A. It contains laptop A. I want to go to the printer P1. This is the printer P1, and I want to print this abc.pdf. abc.pdf. This is the PDF name that you want to print. That also put into this packet. Then this whole packet is transferred to the switch. Then switch transfer to the printer. This is how you are performing the printing activity in your office network. And I want to teach you about this switch and how this switch performs its activities. Route. A router is a networking device that forwards data packets between computer networks. Routers perform the traffic directing functions on the internet. Now, what's the story of this router is? It's another networking device. It forwards packets between computer networks. Now, previous case, switch is mainly focusing on packet switching to receive and forward the destination device. It's mainly focused on the destination device. But router is mainly focusing on another device that is located in the internet. That means it might be in a different network. Now you are in a different network. We think this is LAN 1, this is LAN 2. You two are in different networks. So if you want to communicate in between these, switch would not able to perform this activity. You need a router. Now this is one of simple example of your router. So router is nothing that it's in your home. Now this is a wired communications. If you are using in Sri Lanka facility, you have a separate cable is coming from somewhere. Then there's a modem and it connects to this your Wi-Fi router. There's a plug, obviously, to make sure the power enabled. Now, if you are purchasing facility something, facility router, so make sure to have a plug around the place that you want to locate. If not, they would not able to do this activity. So make sure to have a power source. So, and they will do this cabling and they'll fix this and they'll fix this one also. connect the router. Right. So that's the router, and this is another router. If you are using Dialog, Mobitel, like I saw another router, you don't have this wired connection. Instead of that, your router directly connects to the internet. So this is a router. So if we get like, if we get a situation like communication in between the router and switch, and this is the whole story. Now you may see, this is your modem and this is your router, and this router connects to the switch, then this switch connects to the required hardware devices. So this is the normal story if you are using a wired connection to communicate in between yourself and stuff. So don't think about these numbers. We'll discuss these things later on. But for now, what you have to understand is switch and router and how the internet is connected to your laptop. So you might not using a switch. Instead of that, you are using directly wireless connection, or it might be you directly connect to the router to your laptop because you are in your home network. But if you are in a working environment or a company, you might unable to directly connect to the router. This is the story that I want to tell you. Now we'll do some small activity. We'll check our internet bandwidth. Now what you have to do is you have to open your terminal and type net sh wlan show interface. Shall we do it now? I'll give 1 minute. Okay, let me demonstrate you. I'll open my share my screen. Now I have shared my screen. I have pressed my Windows button. Then I'll type CMD. Then my command prompt will open. So this is a different screen. This is not the screen that you are seeing. Right now, what I have to do is I have to get this into a command like we have done previously few commands and netsh wlan show interface. Now you may see the information. This is the received data. I'm not discussing about these things for now, but for now I want to inform you, I want to teach you the receive rate and transmit rate and the signal strength. So that means I'll receive the data in bandwidth. That is not the speed. There's a common miscommunication in between bandwidth and speed. Bandwidth means the width of your data can be transferred. I'll give some simple example. If you have a very wide road, that means lot of vehicles can transfer same time. If your road is very narrow, අපි කියන්නේ අඩිපාරක් වගේ කියලා. අඩිපාරක් වගේ කියලා. එතකොට it's really hard to travel lot of vehicles same time. So my bandwidth is upload bandwidth and download bandwidth is high. So I change to the other network. We'll see the results. I have changed to the dialog. Then we'll see. So you will see the bandwidth is little bit low than upload and download bandwidth, but network signal strength is high. That means we can communicate in strong network connection. Now in this case the signal strength is lower. It depends time to time based on the devices that connected and how many devices are transferring data in the given time. Such kind of things are affected, but the core important things are the receive data and transmit data and the signal strength. So to have a proper communication, you should have a proper signal strength. I'll give another 30 seconds. You may try by yourself, please. Then you will get some sort of hands-on. If you have any questions, you may ask. Open your command prompt and type netsh wlan show interface. We'll move towards now network classification based on the size or the scale: PAN, LAN, MAN, and WAN. So you know PAN, LAN, MAN, and WAN. These are very common classification for a network. So the PAN, personal area network, is very small scale network. Range is around 1 to 2 meters. That means beyond that you can't connect devices to this PAN, personal area network. Wireless network that connects a computer with its peripherals. So usually in your home you might use a small PAN. And LAN is little bit larger than PAN. LAN is a computer network that interconnects computers within a limited area, such as residence, school, laboratory, university campus, or office building, wherever. If you are connected in between, not with a small area like 1 or 2 meters, it might be 60 meters, it might be 75, it might be sometimes totally different location. Another land might be geographically located, but you may in the same land. So that is a land. This is larger than the PAN, and it communicates in between a limited number of devices. That is not. Then man is larger than LAN, and it has communication between in between lot of areas interconnect, not in a special single area or a special single network. Instead of that, it has a lot of it has lot of areas to cover in same time. So this is a man, and it can share the regional resources. It might be a connected network of LANs commonly, or it might be separated set of LANs might be available in a WAN. This is very large, so two or more LANs are definitely connected to communicate. Now, one LAN is in another country, and this is another country, and this is the LAN. So it can communicate in between different geographical as well as different local area networks, different LANs. It connects in between. So ultimately, WAN can communicate with very large geographical area, some usually around the world. So usually we should use phone lines or satellite to communicate in between these areas, and internet is a WAN. So what you have to think about is, in your perspective, what you have touched is a WAN, a popular WAN is internet. Now, network classification by topology. I do not want to discuss about this bus, ring, star, and mesh topologies. I'll create a self-study link for you. You may upload it and complete the activity. Internet. The internet is the global system for interconnected computer networks that use the Internet Protocol Suite (TCP/IP). So this is the TCP/IP is the common internet protocol suite to link devices worldwide. So what's the purpose of this story is, we all are interconnected in different with the different computers and different servers. We all are connected. If you are using Facebook, you are connected to Facebook servers. If you are using Twitter, you are connected to Twitter servers. Likewise, we have different computers and servers. Sometimes your friend is uploaded the photo from that person's mobile phone. Then all of a sudden, within few seconds, not even few seconds, probably for like milliseconds or nanoseconds, the data is available for you. The whole transmission was conducted. That much of speed is there. Every computer on the internet is assigned to a unique internet protocol address. Now, the story is how to identify a computer in the network. Your home can be identified an address. Your home has a separate set of attributes to identify. What is the city? What is the village? What is the road? What is the home number? If someone needs to communicate or send a letter to you, they have to use your address. It's not duplicated. Your home address is not duplicated. No one in here having the same address. So that's a problem. In the same way, computers using a unique internet protocol, IP address. So this IP address is a unique address for every computer to uniquely identify a computer in the internet. IP address is a unique address that to uniquely identify what is this computer. Packets are routed to destination using these IP addresses. Now, I told the data packet is transformed. Data is transformed using packets. So these packets are routed to the destination using this IP address. Why? How? Why we want to transfer our document to specific printer? I'll draw this story. Now your computer is in here and your printer is in here. Now I told there's a packet transferring mechanism is there to transfer the packets in between these two devices. So if you get an address of ABC, I think it's ABC, I think it's A, right, ABC. Now if we want to, this is the address, right, number 15, Main Road, Panathura. Number 15, Main Road, Panathura. This is the address of this house. In the same way, this is the address of this device in internet. And you want to send a letter to number 15, Main Road, Anuradhapura. So what you write in here, if you are registered post, you send him by this person, received to this person. And you packet this into a envelope and seal it and hand over to the relevant person or the relevant location. Then that person's responsibility is transfer the information to this person. How this address is identified? Because you have mentioned in here in your registered post, I want to send this letter to this one. So this person is not a friend of you, but this person can read this information and transfer the information packet to the relevant destination because of this address. Now, if we map into the computer world, if your address is ABC and I think it's 1.12.162 or something, like some address is here. So there's another address 192, 162 something. Some address is there. This person, this device is having understanding of this information bit is arrived from this address and this information is transferred to this address by using this IP address. It's a unique one. So now you are clear about what is IP address. IP address is a unique address that used to identify a device in the network. Now, IP address, a logical address to uniquely identify a device known as host device in a network. Now, You have connected to a network, and your office, there are a lot of computers. All these computers are known as host. Another new word you have to remember. This is a host, this is a host, this is a host, this is a host, and this is also a host. And this is a network. This network might connected to some another network, or it might be directly connected to internet. Somehow there's a connection in between to this one. So if we draw a boundary, all of these devices should connect to this network. If not, we can't transfer. And this is a logical address. What's the purpose, what's the story, or what's the meaning of this logical address is, it's not based on your physical hardware device. That means it's not fixed to your computer. It depends and it's change according to the service that we are using, according to the service or according to the network service provider or whatever. it it's changing. Now I'll give a simple example. You might have a handphone. This is just a handphone device. It might be manufactured by Samsung or Xiaomi or Nokia or some another. But your mobile phone number is not depend on your hardware device. It's a logical number, 071 072. It depends on the provider that you are getting. Now you're clear about what is this logical address. It not depends on your hardware device, whether you are using a Nokia one or if you are using a Samsung one. Your phone number is a fixed one for you. It's a logical number. It assigns for you. It's a logical number. It's not dependent on your hardware device. What is an IP address? An IP address is a numerical identifier assigned to each device connected to the internet. Now, I have told it's a uniquely identified, and this story, this sentence is mentioning it's a unique number. That means there's a number. It's a software logical address, not a hardware address. I spoke to you that IP addresses are unique. They are unique in the sense of each address defines one and only connected to internet. Two devices on internet cannot have the same address. So we don't have the same address to different devices. Currently, there are two flavors, IPv4 and IPv6. There are two flavors, IPv4 and IPv6. So these two are the mainly we are using the IP address or to give the names IPv4 and IPv6. We are mainly focusing on this IPv4, Internet Protocol version 4. We are mainly focusing on IP addressing. I told you it's internet addressing, IP addressing. For IP addressing, there are different versions are there. You know, everything evolved with from started point to current. This evolve is mentioned by these versions. So internet protocol addresses are mainly identified or mainly focused on this IPv4 currently, but sooner or later it would be not a valuable thing in the next, probably next 2 decades. IPv4 will finish, but for now we'll learn this IPv4. Now it's a version in number. Now find your IP address. What you have to do is you have to open the command prompt again, then type IP config. I'll give 1 minute for you. You open your terminal command prompt and type IP config. Can you please share your IP addresses with me? Take a screenshot and check with me. Just check me. Enable. Check. Yes, now you can check with me. I would like to see some sort of outputs from you. IP address of your IP address. What's your IP address? This is very important. If you are once you join to your job, they'll definitely ask time to time due to different reasons. What's your IP address? Yes, I'm getting responses. Few more. Yes, nice. Thank you. Now I'll open my terminal and share with you. Yes, thank you. Now I'll share my screen. I'll share my command prompt directly. Now I'll type ipconfig. Now you may see IPv4 address. IPv4 address, that is 192.168.1.3. This is the IP address we are speaking. This is the IP address we are speaking. So that means this is a unique number in my network. This is a unique number in my network to identify my hardware device that is currently connected. We'll back to the lesson again. Now IP addressing IPv4 IP addresses 32-bit identifiers. That means there are 32-bit IP addresses are there. What is the meaning of this 32-bit means? Your network is transfer or your identifier, sorry, not transfer, identifier is having length of 32 bits for a given time. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, likewise 32. Why it's 1, 1 or 0? Why it's 1 or 0? Because computers are transfer or identify the information or identify the network or the numbers through binaries. So you can't transfer 198, 192. It should transfer this 192 into binaries. Binary. Now I'll show you later on this transfer. If you know to perform this activity manually, it's okay. If not, we can use any tool to convert this number into binaries. Now 32-bit means you may see it's 192 something, 192, 168, 13, 192, 168, 168, 1, 3. This is my IP for now. There are 4 parts. Each part is having 8 bits. 8 into 4, 8, 8, 8, 8. So that means there's 8 bits in here, 8 bits in here, 8 bits in here, 8 bits in here. Altogether it's 8 into 4, it's 32 bit. So if it is 8 bits can be contained in a one component. The maximum value is 256, 2 to the power 8. Why it's 2 to the power 8? For each and every time we can get 1 or 0. So 2 variations are there. 8 numbers can be here. So 2 to the power 8. 8 numbers in here and 2 variations are there. So altogether 2 to the power 8. But actual case is different. It starts from 0, so it's changing. We'll discuss it. Not 5, we'll discuss it later on. But I just want to teach you. This is a 32-bit identifier. That means each part is having 8 bits. Now, this is known as dotted decimal notation. What is this dotted decimal notation? Means your 192 is converted into decimal binary numbers, into binaries. Once this convert into binaries, there might be a value 101010 something, and again there is a dot. Let me share my screen and from here. Okay, see, this is 192 and there's a dot, and 168, then dot, then 1 dot, then 3. This is the dotted decimal. Why it's decimal number? Why it's dotted decimal? Because binaries are divided into 4 parts. Binaries are divided into 4 parts. In that case, we have 32 bits in here. So the 32 bit is divided into 4 parts. If this is a little bit confusing, don't worry. While we are moving towards, you may understand it well. Now, again, I'll give an example. So this is 223,174. Now, this is in dotted decimal, right? This is in dotted decimal. Now, this one is mapped to here. This one is mapped to here. This is the binary value of this. And this one's binary value is this one. And this one's binary value is this one. What is this one? 1, 2, 4. Here it's 1, 2, 4. 4 plus 4, 2, 1. So that is 7. And this is 1. And this is 1, 2, 4, 7, 8. Sorry, 8, 16. Likewise, it's moving. So the value of here is 223. Clear? What is this dotted decimal notation is? Your values, your binaries can be mapped into, your binary values can be mapped into decimal dotted values, dotted decimal values. So that is not 223 point 1.7.4. No, that is not the interpretation. These are 4 separate components with 4 dots. That means it's separated by 8 bits. Now you may see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. 8 is here, again 8 is here, 8 is here, 8 is here. This is 8. 8 bits are here, 8 bits are here, 8 bits are here, 8 bits are here, 8 bits are here. 8, 8, 8. Altogether it's 32 bit. It's 32 bit addressing. Clear? The මෙතන තියෙන්නේ 32 bit identifier එකක්. ඒ කියන්නේ මෙතන තියෙන bits ගාන මෙතන තියෙන 10 පාදයට තියෙන සංඛ්‍යා ඔක්කොම ද්විමේය සංඛ්‍යා බවට හරවලා ගත්තට පස්සේ මෙතන තියෙනවා 32ක්. දැන් තියෙනවා 32ක්. මේක 32 තමයි මේ IPv4 එකේ කතා කරන 32 bit address එක. එතකොට මෙතන කලේ 223 මම මැප් කළා binary වලට. එක මැප් කළා binary වලට, 7 මැප් කළා binary වලට, 4 මැප් කළා binary වලට. හරිද? Anyone having any question you may ask now? You can unmute and ask.
SSM සර් මේ බයිනරි කරපිට පොඩ්ඩක් කරක් කියලා දෙන්න පුළුවන්.
මේක binary කරේද?
ඔව්.
මේ දැන් නම්බර් එකක් binary කරන විදිය දන්නේ නැද්ද ඔයගොල්ලන් අර අපි හිතමු 7 කියලා. 7 කියන එක දෙකෙන් බෙදෙනවා. එතකොට එකක් අයින් කරන්න ඕනේනේ. එතකොට මෙතන 6යි. 7න් එකක් අඩු කළාම 6යිනේ. එතකොට මෙතන 6 තියෙන්නේ. 6 දෙකෙන් බෙදුවාම 3යි. එතකොට මේක ආයෙත් සැරයක් මම දෙකෙන් බෙදෙනවා. එතකොට මෙතෙන්ට ආයෙත් මෙතන දෙකෙන් බෙදන්න බෑනේ. එතකොට මම එකක් අයින් කරනවා. එතකොට මෙතන ඉතුරු වෙන්නේ 2යිනේ. 2 එක ගන්නවා. එතකොට මම අනිත් පැත්තට මේ ටික කවුන්ට් කරගෙන ගියාම 1 මෙතන 1 එක තමයි මෙතනට ගත්තේ. මෙතන 1 එක තමයි මෙතනට ගත්තේ. මෙතන 1 එක තමයි මෙතනට ගත්තේ. 1 1 1 ආවි. මේ 1 1 1 තමයි මෙතන තියෙන්නේ. එතකොට 8 bit නේ. bit 8ක් තියෙන්න ඕනේනේ. එතකොට මෙතනින් 3ක් දැම්මා. ඉතුරු ටික බිංදු දැම්මා. ඉස්සරහට බිංදු දානවා. ඉස්සරහට බිංදු 5ක් දානවා. මොකද 8ක් වෙන්න ඕන නිසා. බයිනරි කරගන්න දන්නේ නැද්ද උඹලා? බයිනරි කළා නැද්ද මීට කලින්? නම්බර් එක.
නෑ සර් IT කරලා නෑ කවදාවත්. IT කරලා නෑ මීට කලින්.
නෑ මේ හරි මෙහෙම කරමු. අපිට ඔන්ලයින් ටූල්ස් ඇතිනේ. ඉතින් මම ඔන්ලයින් ටූල් එකකින් පෙන්නන්න ඕගලන්ට. පේනවද මම මේ බ්‍රවුසර් එක ඕපන් කරලා තියෙන්නේ දැන්? පේනව නේද?
Yes, sir, yes.
උඹලට පුළුවන් මේ වගේ ටූල් එකක් පාවිච්චි කරන්න. දන්නේ නැත්නම් අපි හිතමු මෙතන තියෙන්නේ 7 කියලා. මම මේක බයිනරි වලට කන්වර්ට් කරනවා. එතකොට බයිනරි වලට කන්වර්ට් කරාට පස්සේ 111 එන්නේ. එතකොට මම ගත්තොත් මගේ ඉස්සෙල්ලා තිබුණේ කීයද 223 නේ. 223 ගන්නම් මෙතෙන්ට 223 දැම්මොත් මම මේක කන්වර්ට් කළාට පස්සේ මේ නම්බර එක එන්නේ. මම ස්ක්‍රීන් එක ෂෙයා කරන්න. දැන් මෙතන තියෙන නම්බර එක. එතකොට මෙතන තියෙන නම්බර එක බැලුවොත් එහෙම ඒ නම්බර එක තමයි මෙතන තියෙන්නේ. හරිද උඹලන්ට පේන ඇති මෙතන තියෙන පේනවද මගේ ස්ක්‍රීන් එක මෙතන තියෙන නම්බර එක මේ 10 ඊට පස්සේ ඉතුරු ඔක්කොම 1 නේ තියෙන්නේ මේ නම්බර එක තමයි මෙතන තියෙන්නේ එතකොට උඹලන්ට ඕන නම් ඕන වෙලාවක මේ වගේ ටූල් එක පාවිච්චි කරන්න පුළුවන් මේ මැනුවල් හදන්න ඕනේ නැහැ යුනිවර්සිටි ස්ටුඩන්ට්ස් ලානේ ඒකින්ද මේ ඕන නම්බර එකක් මේ වගේ IP ඇඩ්‍රස් එකක් ආවොත් එහෙම ඔයගලන්ට කරන්න තියෙන්නේ මේ නම්බර එක අරගෙන බයිනරි වලට කන්වර්ට් කරගන්න. දැන් මෙතන තියෙන්නේ 223නේ 223 අරගෙන මේක බයිනරි වලට කන්වර්ට් කරලා ගත්තා. ඊට පස්සේ ඊළඟට තියෙන්නේ 1 නේ. 1 කියන එක කන්වර්ට් කරනවා මෙතනින් 1 කියන එක නම් ඉතින් 1ම තමයි එන්නේ. 1 එන්නේ. එතකොට 1 දැම්මා මෙතෙන්ට. 1 දැම්මට පස්සේ ආයෙත් 8 bit නේ. තව bit 8ක් තියෙනවානේ. එතකොට ඉතුරු bit 7 මෙතෙන්ට දානවා. මෙතන 1යි මෙතන 7යි. එතකොට 8යි. ඊට පස්සේ මෙතෙන්ට ආයෙත් සැරයක් 7නේ තියෙන්නේ. මම 7 දැම්මොත් එහෙම කන්වර්ට් කළාට පස්සේ 1 ඒවා 3ක් තියෙන්නේ. 1 ඒවා 3 දැම්මා. එතකොට 3යිනේ. එතකොට තව කීයක් අඩුයිද? 8 bit වෙන්න තව 8ක් 5ක් අඩුයි. එතකොට තව මම ඉස්සරහට බිංදු 5ක් 1 2 3 4 5යි කියලා දැම්මා. දැම්මට පස්සේ මෙතෙන්ට එනවා ඒ උත්තරේ. ආයෙත් මෙතන 4 තියෙන්නේ ඒ විදිහටමයි. එතන 4 ගත්තා කන්වර්ට් කරාට පස්සේ මේ තියන්නේ ඉලක්කම් 3 ඉතුරු ටිකට බිංදු දානවා ඉස්සරහට. කන්වර්ට් කළාට පස්සේ මේක තමයි කන්වර්ෂන් එකේදී අන්තිම උත්තරේ වෙන්නේ. ඒතකොට මේක තමයි ට්‍රාන්ස්ෆර් වෙන්නේ ඉන්ටර්නෙට් එක through communicate වෙන්නේ. Clearද? Anyone is not clear? Now it's clear or not?
Clear sir, clear. Okay.
Okay. Right. Right. Now it's 32-bit identifier and it's dotted decimal. So these are the numbers. So if we speak about the smallest number, smallest IP address is it should be 0000 because everything is 0. මෙතන ඔක්කොටම බිංදු දැම්මොත් එහෙමනේ smallest IP address එක වෙන්නේ. But it's not the story. It's 1000. 100. This is the smallest number and the largest number should be 256 256 256 256 256 වන එන්න ඕනේ මෙතෙන්ට මොකද 2 8 බලයනේ 2 8 බලය එනකොට 256යිනේ 2 8 බලය 2 4 8 16 32 64 128 256 හරිනේ එතකොට 2 8 බලය එන්න ඕනේ එහෙමනේ now if we discuss about like in that case it should be 256 256 for each position it's 256 but since it's starting from 0 we have to get back to not from අපිට බිංදුවෙන් පටන් ගන්න වෙන නිසා එකෙන් පටන් ගත්තොත් 256යි හැබැයි බිංදුවෙන් පටන් ගන්න නිසා ඉලක්කම් 256ක් තියෙනවා බිංදුවෙන් පටන් ගන්න නිසා බිංදුව 1 2 3 4 ගත්තට පස්සේ maximum එක ඉවර වෙන්නේ 255යි the maximum value is 256 because it starts from the 0 right because it starts from 0 if it starts from 1 then it should be 256 but since it starts from 0 we have to end in 255 that's the reason to 255 so this is the largest IP address that we can generate I think everyone is clear කාට හරි ගැටලුවක් තියෙනවා නම් අහන්න ask me any question that if you have any question you can chat with me because we have to clear this one before going to the next things මම එකයි චුට්ටක් අද වෙලා වෙයි වැඩිපුර but we want to clear you මට උඹලට clear කරන්න ඕනේ මොකද මේ නැත්තම් උඹලන් අමාරු වෙනවා තව චුට්ටක් ඉස්සරහට යනකොට ඊළඟ ටික නැත්තම් තේරෙන්නේ නැති වෙලා යනවා any questions no right හැමෝටම තේරුණා මේක 32 bit කියන එකයි dotted decimal කියන එකයි තේරුණා right now we'll give a small activity for you so try to convert these IPs. So these IP addresses are in binaries. There are 2 IP addresses. These are binary numbers. So what I'm asking is, I want to find the binary numbers that is representing IPv4. IPv4 එකේ අපිට පේන විදියට. Let me share the screen again. Now, what I want to do is, I want to convert this number into base 10. This number into base 10, this number into base 10, this number into base 10. Then you will get 1, 2, 4, 8. So this is 11. 11 dot. Then this is 1, 2, 4. This is 4. This is 1. So it's 5. Clear? This is 1. This is 2. This is 4. This is 8. We are considering only ones. 8, 2, 1. 8 plus 2 plus 1. 8 plus 2 plus 1. 8 plus 2, 10. 10 plus 1, 11. 4 and because 0 is not considering. 4 plus 5. Sorry, 4 plus 1, it's 5. Can you perform and chat with me? ඔයාලට කළ චුට්ටක් මට chat එකට දාන්න පුළුවන්. Then I can confirm that you have understood this dotted decimal story. I'll give 1 minute. You can use a tool even if you are unable. This is very easy. මේක හරි lazy. මේක මොකද්ද මෙතන තියෙන්නේ? 1, 2, let me write 1, 2, 4, 8, 16, then 32. මේ වැඩි වෙවි යනවා දෙකෙන්. It's multiplied by 2. That's it. 1, 2, 4, 8, then 16, 32, then 64, then 128, then 256. You can chat with me and confirm that you have understood or not. I'll give another 2 minutes. Today lesson might be extended another hour probably, because still we are in 18th slide. Around 40 slides are there. So, but ඔයාලට clear කරන්න ඕන නිසා මම චුට්ටක් අද වැඩියෙන් වෙලාව ගන්නවා. Right? Convert this and let me know if you have any questions.
Sir, we have the math session at 10:15.
Sorry?
We have the maths lecture at 10:15.
We have to?
We have the maths lecture at 10:15.
I can't hear you. I can't?
We have another lecture at 10:15. The maths lecture.
You have another lecture at 10:15. All right. Okay. Then we'll do evening. The rest of the lesson we'll do at evening. Oh, yes, we'll do at evening. Okay. So I'll stop whatever the point that we are discussing in here. Then the rest we will continue at evening. Right. Let me know you have cleared or not. Chat with me. So share your answers with me. Any problems, troubles in this transferring? I haven't got answers. Why you can't chat with me? Any problems? Okay. Mm, I hope that you are clear. We'll do another activity. Now convert these IP addresses into binaries. Convert this one. I'll give another 2 minutes and get clear that you are. sharing is gone, right? sharing එක ගියා නේද? ඇහෙන්නේ නැද්ද? Can't you hear me?
So sharing එක කිව්වේ
මගේ screen එක
screen එක තියෙනවා සර් තාම. annotations ටික තමයි ගියේ.
screen එක නෑනේ මට.
අපිට screen එක පේනවා හැබැයි freeze වෙලා වගේ.
එකක් හරි වෙලා නේද?